Alright guys, today we're going to go over section 5.5. It's the last section we'll shoot out of this unit before we take our test. We'll take our Unit 5 test on Friday. And section 5.5 covers multi-angle and product to sum formulas. And so if we start with our double angle formulas, for sine and tangent, they're really easy. For cosine, there's 3 different double angle formulas. So yeah, all of them were used as like an x. You could use x too. Alright, so your double angle formula for sine is that sine of 2u equals 2 sine of u times cosine of u, which is the simplest of all of the formulas. Like I said, cosine is the most complicated because there's 3 different formulas that you can use for a double angle formula for cosine. So the first one, cosine of 2u equals cosine squared of u minus sine squared of u. Or you can write cosine of 2u as 2 cosine squared of u minus 1. Or you can write it as 1 minus 2 sine squared of u. And then the last double angle formula that we have is our tangent formula for a double angle. Alright, everybody got those? Yes, okay. Alright.
This one for tonight is on multi-cement.
Well, there you have it. Okay. So the first one it asks us to solve is 2 cosine of x plus sine of 2x. And so we can't do anything with a 2 cosine of x, but we know our double angle formula for sine of 2x is 2 sine of x cosine of x. So I know that if I simplify that, I have 2 cosine of x plus 2 sine of x cosine of x equals 0. A 2 cosine out, yep, so then we're going to factor out this 2 cosine of x. So if I factor out a 2 cosine of x, from both terms of factor out of my first term, all I'm left with is 1. And if I factor it out of my second term, I'm left with sine of x. Once I get here, then I know that I can break it up into 2 cosine of x equals 0, or 1 plus sine of x equals 0. And solve them each individually. So if I go to solve this one for 0, I start by dividing by 2. 0 divided by 2 is 0. So I only care about my x's when cosine of x is equal to 0. So Where is my cosine of x equal to 0? Okay, yeah, is 0 cosine 0 is 1. Yeah, no, it's not 0. So I think pi over 2 and, okay, so pi over 2 and 3 pi over 2. So that part's solved, so then I need to solve this other one for sine of x. I subtract 1, subtract 1, so sine of x equals negative 1. And so where is my sine of x equal to negative 1?
Jared, please come to the school office. Jared, all you please come to the school office, please.
Where is my sine of x equal to negative 1? 3 pi over 2 and where? Is that it? Just 3 pi over 2? Okay, so I know that my x is pi over 2 or 3 pi over 2. Okay, let's do it one like that. So I'm given cosine of 2x plus cosine of x equals 0. Okay, and so we can simplify our cosine of 2x. No, you can't do that. You have to use one of your double angle formulas. So we can use cosine squared of x minus sine squared of x, or 2 cosine squared of x minus 1, or 1 minus 2 sine squared of x. Because my other term in here is a cosine, I'm going to use this one. That way I'll get down to just cosines. So if I replace this with that, then I get 2 cosine squared of x minus 1 plus cosine of x equals 0. That way now I'm dealing with their cosines at least. I knew that the other part of my equation was just a plus cosine, and so it's easier to simplify things if they're all the same term. So I wanted everything to be a cosine. Okay, so this is just like any other polynomial. So 2 cosine squared of x plus cosine of x minus 1 equals 0. All I did was rewrite it so that it's in standard form. And this is actually factorable. I'm going to move that down. Because I know that 2 times 1 is 2, and factors of 2 that subtract to be positive 1 are 2 minus 1. So I end up with 2 cosine squared of x plus 2 cosine of x minus 1 cosine of x minus 1 equals 0. So this is just like any other polynomial that you would factor. So then if we factor that out, I can factor out a 2 cosine of x from my first term, and I'm left with cosine of x plus 1. I can factor out a negative 1 from my second term, and I end up with cosine of x plus 1. So I know that this factors to 2 cosine of x minus 1 times cosine of x plus 1. Everybody kind of follow how I factored that? It would be like as if this were 2x squared plus x minus 1. Just like that type of polynomial. Except instead of x's, you're dealing with cosines. There is actually one like this on your quiz. Just FYI. Just for extra credit though. Alright, so then if you break it into 2 different problems, 2 cosine of x minus 1 equals 0, and cosine of x plus 1 equals 0. Then we can solve those for cosine. So add 1 to both sides, and I end up with 2 cosine of x equals 1. And if I divide by 2 to both sides, I end up with cosine of x equals 1/2. So where does my cosine of x equal 1/2 at? Okay, so pi over 3 and 5 pi over 3. So that's my first set of answers. And over here, if I go solve this for cosine, I subtract 1, subtract 1. So cosine of x equals -1. And where does cosine of x equal -1 at? Pi. So x equals pi over 3, 5 pi over 3, or pi.
When it's active, first activate, it's 2 cosine of x instead of 5.
Oh, that's just how I kept in my head that I split that and where I factored those two, and then I factored these two separate. Okay. So if I look at example 2a, I'm supposed to simplify this so that I can graph it. Okay, and you guys are going to graph them in your graphing calculators. But let's look at how to simplify it. So the first thing you always want to do is you want to try to factor. I have a 4 and a 2, so I'm going to factor out a 2 from both my terms. So if I factor out a 2 from that 4, I end up with 2 cosine squared of x. Now if I factor out a 2 from that 2, I end up with -1. And we factored it so that we could get this to hopefully look like one of our double angle formulas. So are any of our double angle formulas 2 cosine squared -1? Okay, so which one? Cosine of 2u, right? Or cosine of 2x. So then I can replace the 2 cosine squared -1 with cosine of 2x, and I still have that 2 out front that I factored. So this simplifies down to 2 cosine of 2x. And so then that is what you put in your graphing calculator. Alright, so I'm going to do the same thing. For example, 2b, I'm going to try to get this to look like one of my double angle formulas. And the first thing I notice is I have a 3 and a 6, so I'm going to factor out a 3 from both of my terms. So if I do that, if I factor out a 3 from 3, I end up with 1. And if I factor out a 3 from 6, I end up with 2 sine squared of x. And so hopefully this looks like one of my double angle formulas. Okay, so cosine of 2x, that's that double angle formula. I still have that 3 out front. I end up with y equals 3 cosine of 2x. Alright, and then the last thing that we're going to do is we're going to take angles that were already given and we're going to turn them into double angles. I guess that's the last part that we're doing with our double angle formulas. So I'm given cosine of theta equals 5 over 13. And I know that sine is y over r, cosine is x over r, and tangent is y over x. So then I know that my x is 5, my y is -12, and my r is 13. And they gave you this diagram, just so you know. So I know that x is 5, y is -12, and r is 13. so if I start with sine of 2u or sine of 2x, sine of 2x, but I know that sine is y over r, so sine of 2 times negative 12 over 13 equals, my sine of 2u formula is 2 sine of u cosine of u. So I can simplify that to 2 sine of negative 12 over 13 times cosine of negative 12 over 13. Okay, and then since you don't know sine and cosine, that's pretty much as far as you can go. So you're just rewriting them. So if you do the same thing for cosine of 2u, it doesn't really matter which formula you use. So let's see, I think the easiest one is cosine squared plus 1, or is it cosine squared minus 1? I'm going to go with cosine squared of 5 over 13 minus 1. Because that I think is the easiest one to deal with, is when you're dealing with cosine squared minus 1. But if you think one of the other ones is easier, then use one of the other ones. And then lastly, tangent of 2. Tangent is y over x, so negative 12 over 5. And what's our tangent formula? Does anybody remember? Yep, the double angle formula for tangent. Two tangent squared, or 2 tangent of u minus 1, you said? Oh, just 2 tangent of u over 1 minus tangent squared of u. There we go. Alright, and you won't do very many like that, but just so you know how they're done. Then the other things we're going to look at is our power reducing formulas. And those are the only other formulas we're going to look at from this unit. Alright, so your power reducing formula for sine squared is actually 1 minus cosine of 2x over 2. For cosine squared, it becomes 1 plus cosine of 2x over 2. And for tangent, it becomes 1 minus cosine of 2x over 1 plus cosine of 2x. And you use those when you're trying to get rid of your exponents. Okay. So if I look at example 5a, I'm asked to rewrite sine to the fourth power of x. Right. And I don't have a formula to reduce a fourth root, but I do have a formula to reduce sine squared of x. I'm going to break this fourth into sine squared times sine squared, because then I can simplify each one. Okay, and then my sine squared formula is 1 minus cosine of 2x over 2. So then if I simplify each of these, then I get 1 minus cosine of 2x over 2 for each of them. And then we can multiply straight across because they're fractions. Alright, so figuring out the denominator is easy because 2 times 2 is just 4. Figuring out your numerator, we have to FOIL because these are two polynomials. So 1 times 1 gives me 1. 1 times the negative 2 cosine gives me negative 2, or negative cosine of 2x. Negative cosine of 2x times 1 gives me negative cosine of 2x. And negative cosine of 2x times negative cosine of 2x gives me positive cosine squared of 4x. Because your cosines become squared, 2 times 2 is 4. And then if we combine like terms and simplify that, we get 1 minus 2 cosine of 2x plus cosine squared of 4x all over 4. We'll do the same thing for tangent of 4x. Tangent of 4x is tangent squared of x times tangent squared of x. Okay, and we know tangent squared of x is 1 minus cosine of 2x over 1 plus cosine of 2x. So once we know that, then we can simplify those and FOIL the top and bottom. So 1 times 1 gives me 1. 1 times negative cosine 2x is minus cosine of 2x. Minus cosine of 2x times 1 is minus cosine of 2x. Negative cosine of 2x times negative cosine of 2x is positive cosine squared of 4x. And we'll do the same thing on the bottom. 1 times 1 is 1. Cosine of 2x times 1 is cosine of 2x. Cosine of 2x times 1 is cosine of 2x. And cosine of 2x times cosine of 2x is cosine squared of 4x. And if we combine like terms on the top and the bottom, we end up with 1 minus 2 cosine of 2x plus cosine squared of 4x. over 1 plus 2 cosine of 2x plus cosine squared of 4x. And then you're done with that one. Okay. So you guys are going to work through page 413, 11 through 51, just do the odds. We're going to do that today and tomorrow. And then Wednesday, Thursday, we'll review for your test. Friday, you will take your test.